Hello and welcome. Today, we're diving into an AI architecture that doesn't just predict the future, it actually programs it. It's called a meta-temporal cognitive architecture, and trust me, it's going to make us rethink what time even means for an artificial mind.
So, let's just start with the huge question at the heart of all this. We're all used to AI trying to predict what's next, but what if an AI could literally program its own future? I mean, what if it could treat time less like a river it's floating down and more like a dimension it can navigate, rewrite, and totally optimize?
And that's exactly what we're getting into. We're throwing out the old idea of time as this simple, one-way street that everything has to follow. Instead, we're going to look at an architecture that sees time as something way more complex, and frankly, way more flexible.
And this slide right here, this really gets to the core of the shift. On the left, you've got your traditional AI, which basically experiences time just like we do, one thing after another, in a straight line. But on the right, that's the new stuff. The metatemporal architecture sees time as a temporal manifold. Forget the single track, think of it more like a giant chessboard, where it can explore tons of different moves and future board states all at once. It's working across different layers of thought and through different versions of its own logic.
So how does a system like this actually work? Well, it's built on 4 distinct layers, but it helps to think of them less like boring software modules and more like a team of specialized temporal organisms. Each one has its own job, its own unique sense of time. So let's meet the crew.
Okay, so these 4 work together in this constant loop. Perception grabs the data, inference tries to make sense of it, projection games out what could happen next, and evaluation scores the results. This whole cycle is basically the cognitive heartbeat of the system. Let's break down each one.
First up is perception. This is the system's eyes and ears on the world. It's constantly looking at a fresh, rolling half-second window of data, and to make sure it's not acting on old news, it uses something called exponential decay, which just means older info fades away fast. This ensures every single decision is based on what's happening right now.
Next, you've got the inference layer, which is basically the system's analyst. It takes all that data and comes up with a bunch of different hypotheses about what it all means, and it even tracks how confident it is in each idea. And to keep it from jumping the gun, it uses a technique that's kind of like telling it to just cool down and think through all the angles before it commits. So it's thoughtful, not impulsive.
All right, this is where it starts to feel like science fiction. The projection layer is the strategist. It takes the best ideas from the inference layer and then simulates multiple possible futures. It plays out all these different what-if scenarios, figures out the risks, and, this is the really cool part, it just chops away the futures that are either way too unlikely or just flat out too dangerous. It's got its own built-in future simulation engine.
And finally, there's evaluation, the quality control inspector. It looks at all those simulated futures and the system's performance as a whole. It's constantly asking, are we on track? Are we getting closer to our goal, or are we drifting? Based on that, it creates this crucial feedback that it pumps right back into the system to make the next loop even smarter. This is the real engine of its learning.
And this is where the magic really happens. This feedback loop, it lets the system do something wild, rewrite its own future. Now, it can't change the past, but it can actively tweak its future plans based on what it learns from its own simulations. So how does that even work?
It all starts right here. The projection layer just runs a simulation. It cooks up a detailed what-if scenario. Something like, okay, if I do this right now, what's the most probable outcome in the next 2 seconds?
Then, the evaluation layer jumps in and just picks that simulation apart. It checks it against all its goals and asks, okay, does this outcome actually help us? What's the risk level here? Is this really the best we can do? And from that, it generates a really clear feedback signal, a judgment call on that possible future.
That feedback is what triggers the temporal rewrite. And this right here is the heart of the entire system. The AI uses that judgment call to adjust its whole strategy. It's basically saying, nope, that simulated future wasn't good enough. I'm changing my plan to aim for a better one. Think about that. It is literally learning from futures that never even happened.
You know, this whole idea of simulating and rewriting the future, it naturally leads to a really cool question. How does this formal, engineered system stack up against, well, us, against the most complex time processor we know of, the human brain? Let's dig into that.
This table does a fantastic job of laying out the differences. The AI sees time as this programmable grid of discrete moments. For us, it's just a continuous, real-time flow. The AI has this very explicit rewrite command, but our brains learn through the much slower, messier process of neural plasticity. And get this, if the AI messes up, it can literally roll back to a previous state that worked. I mean, wouldn't that be nice? We're just stuck with learning from our mistakes and trying to remember not to make them again. Our brains are fluid. This AI is formal and layered, with super strict rules governing how everything talks to each other.
And a quote from the original paper really nails this idea. The point isn't to build a perfect copy of the brain. The point is to get inspired by the concepts we see in biology, like prediction and feedback, and then engineer them into a structured, computable system that you can actually control and verify. It's biology-inspired, but engineering-driven.
So what do you get when you build a mind like this? What can an AI that programs time actually do? Well, you get some pretty mind-blowing new abilities that just emerge from the design.
3 really big ones stand out. First, temporal bifurcation. It's a fancy term, but it just means it can explore a bunch of different what-if timelines all at the same time. Then there's temporal encapsulation, which makes sure all those different explorations don't bleed into each other and mess things up. But the biggest one might be self-referential optimization. This means the system can treat its own internal logic like it's a piece of software. It can create new versions, test them out, and if a new update has a bug, it can just roll back to the last stable version. It can literally upgrade itself.
And that brings us to the final thought I want to leave you with. Most learning happens through trial and error out in the real world. But this system, it does its trial and error in simulated futures. So if a machine can learn from mistakes it never actually made in a future it is constantly rewriting to be better, what in the world does that mean for the limits of its intelligence? It's a question that really pushes the boundaries of what we even thought was possible. Thanks for joining me.